Dear friends, welcome to this channel. In this video, I will explain questions from 51 to 60 in JAM 2020 chemistry paper. Question number 51. The heat of formation of MgO at 300 Kelvin and 1 bar pressure is minus 600.60 kilojoule mole inverse. The free energy in kilojoule mole inverse of formation of MgO at 280 Kelvin is. Here delta H at 300 Kelvin is given. You have to calculate delta G at 280 Kelvin. What is the reaction? The reaction is Mg plus of O2 gives rise to MgO. We know that from Kirchhoff's equation, delta H at temperature T2 minus delta H at temperature T1 is equal to delta Cp into delta T. Let us take 300 Kelvin as T2 and 280 Kelvin as T1. You have to find out delta H at 280 Kelvin. Then delta H T1, that is at 280 Kelvin, is equal to delta H T2 minus delta Cp into delta T. What is the value of delta H? Delta H2, this is a value minus 600.60 kilojoule mole inverse. You have to find out delta Cp. Okay, what is the delta Cp value? What is delta Cp? Delta Cp is Cp of products and sum of Cp of reactants. Here, this is the product, MgO is the product, and of O2 and Mg is reactant. So, what is the delta Cp? Delta Cp is equal to 27.0 minus here of O2. So, 29.4 divided by 2 minus 24.9. Okay, you will get delta Cp is equal to, after calculation you will get minus 17.6 joule mole inverse Kelvin inverse. Okay, when you write it in kilojoules, it will be equal to minus 17.6 into 10 to the power of minus 3 kilojoules mole inverse and Kelvin inverse. This is the delta Cp. And what is delta T? Delta T is the difference between 300 Kelvin and 280 Kelvin. It will be obviously 20 Kelvin. So you will get minus 600.60 minus delta Cp value minus of 17.6 into 10 to the power of minus 3 into, you have to multiply with 20. Okay, after this calculation you will get minus 599.248 kilojoule mole inverse. This is the delta H T1, means delta H at 280 Kelvin. You have to calculate delta H at delta G at 280 Kelvin. We know that delta G is equal to delta H minus T delta S. We know the value of delta H at 280 Kelvin, temperature 280 Kelvin, and you have to calculate delta S. What is the delta S here? Delta S is the sum of entropy of product minus sum of entropy of reactant. This one is 0. 0 minus 205.2 minus 0. So this one is equal to minus 205.2 divided by 2. You have to divide with 2 since the amount of O2 is half mole. And this is in joules. Okay, when you convert it in kilojoules, you have to multiply with 10 to the power of minus 3. So you will get kilojoule mole inverse Kelvin inverse. This is the delta S. So when you substitute these values, delta G is equal to delta H minus 599.248 minus delta S value. Okay, what is the delta S value you will get? You will get around 28.728 minus 28.728 you will get when you multiply with temperature. So this term will be minus T delta S term will be minus of minus 28.728. Okay, when you multiply with the temperature 280 into minus 205.2 by 2 into 10 to the power of minus 3 will give minus 28.728. So this one equal to minus 599.248 minus of minus plus 28.728. Okay, you will get finally you will get minus 570.520. So it will be approximately minus 570 kilojoule mole inverse. So what is the answer? The answer is minus 570. This is in kilojoule mole inverse. Question number 52. Seawater containing 1 molar NaCl has to be desalinated at 300 Kelvin using a membrane permeable only to water. The minimum pressure required on the seawater side of the membrane is. Okay, the pressure in terms of bars. Okay, pi is equal to, we know that osmotic pressure pi is equal to mRT. Here m is equal to 1 molarity and R is equal to 8.3 joule mole inverse Kelvin inverse. When you convert this one into in terms of bars, you will get 0.08314 liter bar mole inverse and Kelvin inverse. And here temperature T is equal to 300 Kelvin. So when you substitute these values, you will get pi is equal to 1 into 0.08314 into 300 into 300. Okay, you will get 24.942. So this one is equal to 24.9 bars. So what is the pressure? The minimum pressure required on the seawater side of the membrane is 24.9 bars. A bacterial colony grows via cell division where each mother bacterium independently produces 2 daughter cells in 20 minutes. If the concentration of bacteria is 10 to the power 4 centimeter minus 3, the colony becomes harmful. Starting from a colony with an initial concentration of 5 centimeter cube inverse, the time taken for the colony to become harmful is. Okay, we know that this one is a geometrical progression. Geometrical progression. The growth of bacteria is a geometrical progression. Here the initial concentration A is 5 centimeter cube inverse. And what is the ratio? Here each time the cell divides into two daughter cells. So R is equal to 2, the ratio is 2. We know that in geometrical progression the sum Sn is equal to 1 minus R to the power of n minus 1 minus R. Here n is the number of divisions. Here n is the number of cell divisions, let us take. So after n number of divisions, cell divisions, how many cells you have? Sn is equal to A into 1 minus R power of n minus 1 minus R. So what is the Sn here? Sn is equal to 1 minus 2 power of n 1 minus 2 into 5. So you will get Sn is equal to, that implies Sn is equal to 2 power of n minus 1 by 1 into 5. Okay, this is the Sn. So what is the minimum concentration of bacteria? What is the minimum concentration? 10 to the power 4 centimeter cube inverse. So what is the n value? What is the n value to get 10 to the power 4 centimeter cube inverse concentration? What is the n value? So here 10 to the power 4 is equal to 2 power of n minus 1 into 5. That implies 2 power of n minus 1 is equal to 10 to the power of 4 by 5. It will be equal to 2 into 10 cube. It's a 2000. That implies 2 power of n is equal to 2001. It's a 2001. So what is the minimum n value? What is the minimum n value? Minimum n value is required for the value 2 power of n greater than 2001. Suppose if n is equal to 11, what is the 2 power of n value? 2 power of n value is equal to, we know that 2 power of 10 is 1022 into 2. So this one is greater than, in this case 2 power of n is greater than 2001. So how many minimum divisions are required? The minimum cell divisions which are required is n is equal to 11. Okay, after 11 cell divisions, the concentration will be more than 10 to the power of 4 centimeter cube inverse. We know that for each cell division how much time it is taken. It's taken 20 minutes. For 11 cell divisions it will be taken 11 into 20, it will be 220 minutes. Okay, how much time, the time taken in minutes for the colony to become harmful is 220 minutes. Okay, after 220 minutes, the concentration, the bacterial concentration rises from 5 centimeter cube inverse to 10 to the power 4 centimeter cube inverse. So what is the answer? 220 minutes. 54. The Maxwell distribution of speeds of a gas at 300 Kelvin is given below. The molar mass of this gas is, okay, this is a distribution curve. From this curve, you can predict this is the most probable velocity. This point indicates VMP. Here, what is the value of most probable velocity? Here, VMP is equal to 500 meter second inverse. We know that VMP, most probable velocity, is equal to root 2 RT by M. You have to find out M. So, VMP square is equal to 2 RT by M. M is equal to 2 RT by VMP square. So when you take these values, R value, what is R value? 2 into 8.3 and temperature is 300 Kelvin divided by VMP square, 500 square, you will get 25 into 10 to the power of 4. So here R is in SI unit, joule, mole inverse, Kelvin inverse, it is Newton meter, joule is Newton meter, and velocity is in SI unit, so the mass will be in SI unit. So here mass you will get, it will be equal to 199.2 10 to the power of 4. This is the kilograms. You will get in kilograms. So when you convert it into grams, you have to multiply with 10 to the power of 4 into 10 cube grams. So you will get 19.92 grams. One decimal place you have to, so it will be 19.9 grams. What is the M value here? The M value is 19.9 grams. Question number 55. At a certain wavelength, the liquid P transmits 70%, whereas liquid Q transmits 30% of the incident light when separately placed in a spectrophotometric cell. In a binary mixture of liquids P and Q, assume non-interacting liquids, the absorbance in the same cell is 0.25. The volume fraction of liquid P in the binary mixture is. Okay, here absorbance of P and Q you have to find out. We know that A is equal to minus log T. T is the transmittance. So when it is in percentages, minus log T by 100 when it is in percentage. So it can be written as 2 minus log T percentage. What is the absorbance of liquid P? AP is equal to 2 minus log 70% and AQ, absorbance of Q, is equal to 2 minus log 30. Let us take volume fraction of, this is the volume fraction of P liquid, let us take X. Then volume fraction of Q is equal to 1 minus X. Then total absorbance of mixture A is equal to pi P AP plus pi Q AQ is equal to X into 2 minus log 70 plus 1 minus X into 2 minus log 30. So when you expand this equation, you will get A is equal to 2x minus x log 70 plus 2 and minus log 30 plus minus 2x minus 2x and minus of minus plus x log 30. x log 30. Here there is a cancellation of plus 2x and minus 2x terms. So finally you will get a is equal to, you will get 2 minus x log 70 plus x log 30 and plus minus log 30. Here a is given. What is the a value? 0.25. 0.25 is equal to 2 minus, okay, it can be written as, okay, when you log 70, x log 30 minus x log 70, it can be written as plus x into log 30 by 70 minus log 30. So you have to find out x value. So x log, okay, 0 0 cancel, log 3 by 7 is equal to 0.25 minus 2 and plus log 30. So finally x is equal to, you will get, in this case you will get plus 0.273 and when you divide with log 3 by 7, log 3 by 7, you will get to 0.74. So what is the answer? The answer is 0.74. The mean ionic activity coefficient for a 0.01 molar aqueous solution of Ca3PO4 twice is, okay, this is the equation. Here you have to find out ionic strength. I is equal to, we know that 1 by 2 sigma mi Zi square. Here the molarity of, if you take Ca3PO4 twice, this one is dissociates into 3Ca2 plus and 2PO4 3 minus. So here the concentration is 0.01 molarity of this solution. So you have the concentration of Ca2 plus will be 3 into 0.01 and this one will be 2 into 0.01. And what is the Z value for Ca2 plus? Z value 2, this one is 3. So I is equal to 1 by 2 m1 Z1 square plus m2 Z2 square. Let us take Ca2 plus as m1, PO4 3 minus as m2. 2, 1 and 2. Let us take 1, this one is 2. Then you will get m1 0.03 into Z square, it will be 4 plus m2 is 0.02 into Z square, it will be 9. This one is 9. So you will get 1 by 2 and this one is 0.12 plus this one is 0.18. So it will be 1 by 2 0.30. So it will be 0.15. This is I value. We know that log 10 base 10 gamma plus or minus, it's a mean ionic activity, is equal to minus 0.509 Z plus into Z minus. Here Z plus 3 and Z minus is 2. Sorry, Z plus is 2, Z minus is 3. So it will be 2 into 3, 6. And the root I value, root 0.15. So when you multiply, you will get minus 1.183 minus 1.183. So mean ionic activity is equal to 10 to the power of minus 1.183. This one is equal to 0.0656. Okay, 3 decimals, so it will be 0.6066. You can write 0.066 is the mean ionic activity of this salt. For the reaction CuSO4 plus Zn gives rise to ZnSO4 plus Cu, the value of delta G naught is given. Delta G naught you have to find out. We know that delta G naught is equal to minus NF E naught of cell. Okay, here what is the E naught of cell? Reduction potentials. Here reduction potentials of cathode and anode is given. So simply E naught of cathode minus E naught of anode. Here this is the cathode and this is the anode. So it will be equal to 0.34 minus of minus 0.76. It will be equal to 1.10 volts. This is E naught cell. Then delta G naught is equal to minus NFE. How many electrons are involved? In this case, 2 electrons are involved. So minus 2 into F 96485 into this is a 1.10. So you will get, what is the value you will get? You will get minus 212.267 joule mole inverse you will get. We know that this is a coulomb. 1 coulomb volt is equal to 1 joule. So here delta G naught in terms of joules, you have to convert it into kilojoules. Here kilojoule for mole inverse mole. So it will be equal to minus 212.267. When you convert the joules into kilojoule, you have to multiply with the minus 3, 10 to the power of minus 3 kilojoule mole inverse. So you will get finally minus 212.267 kilojoule mole inverse. Round off to the nearest integer, it will be minus 212. What is the delta G naught value? Minus 212 is the delta G naught value of this cell. Titanium tetrachloride reacts with THF to form an octahedral complex X under inert atmosphere at 25 degrees centigrade. If 5 gram of TiCl4 is used and the yield is 80%, the amount of X in grams formed is. Okay, what is the reaction? The TiCl4, when you react with THF, tetrahydrofuran, it reacts with 2 moles of tetrahydrofuran. Here there is a formation of octahedral complex 2THF. So we know that tetrahydrofuran, this is a tetrahydrofuran. What is the molecular formula? C4H8O is the molecular formula. Here you have to calculate molecular weight of TiCl4 and also TiCl4-2HF complex. What is the molecular weight of TiCl4? 48, and this one is 4 into 35.5. 4 into 35.5. So you will get 4 into 35.5. It will be, obviously it will be 1 4 and 4 5 22 1 142.0. So what is the weight? It will be 190 grams. This is the molecular weight. TiCl4 is 190 grams. And if you calculate TiCl4 2HF, for tetrahydrofuran, if you calculate, you will get 72 for tetrahydrofuran. For two molecules, you will get 72 into 2. It will be 144. 144 plus 190. You will get 4, 3, and 334. This is the molecular weight of TiCl4. This is a 334 grams. This is the molecular weight of TiCl4 2HF. Here, how many grams of TiCl4 reacts? 5 gram of TiCl4. Okay, 5 grams means how many moles? Number of moles of TiCl4, 5 by 190. So you will get how many moles? You will get 5 by 190 means you will get approximately 0.026316 moles. So from this equation, 1 mole of TiCl4 gives 1 mole of TiCl4 2HF. So how many moles of complex X will be formed? This is a complex X. The number of moles will be 0.026316 moles of X will be formed. Then what is the weight? What is the weight of TiCl4 2HF? You have to multiply with 0.026316 with molecular weight. What is the molecular weight? 334. This many grams you will get if the reaction is 100% yield. So you will get 8.789 grams. You will get 8.789 grams of complex X when the yield is 100%. When yield is 80%, then simply you have to multiply with 80 by 100. So 8.789 into 80 by 100. You will get 7.031 grams. So what is the amount? 1 decimal point you have to approximate. It will be 7.0 grams of X will be formed. Question number 59. The total number of tautomers possible for 1 and 2 together is. Okay, let us take a first structure. Here you have NH and this one is pH, and this side you have NH and pH. This is double bond. Here this nitrogen has lone pair of electrons. These electrons come in between carbon and nitrogen, and these electrons move, and these electrons move like this, and here these electrons come like this, and there is a migration of hydrogen to the oxygen. So what is the tautomeric structure of this molecule? This is the tautomeric structure. Here you have OH, and this is double bond. This one is NH, pH, and this one is double bond. This one is double bond N. Here you have phenyl ring. This is the phenyl ring. Let us take phenyl ring. And this is the phenyl ring you have, and here there is a double bond O. And again, there is a participation of pi electrons of phenyl ring like this. These electrons moves like this, and these electrons moves like this, and these electrons moves towards like this, and these electrons moves. And this hydrogen migrates to this oxygen, and you will get another tautomeric structure. That is, here you have OH, and this one is OH, and here you have double bond, this one is N, and this one is NH, PH, and this is the structure you have. This is the double bond N. Here, in this case, there is a participation of ortho hydrogen and this para hydrogen and also ortho hydrogen. So, if you take one phenyl ring, how many hydrogens will participate in tautomerism? Two ortho positions, two ortho hydrogens, and one para hydrogen. So, per one phenyl ring, there is a participation of 3 hydrogens. These 3 hydrogens will participate in tautomerism, and this hydrogen will participate. Again, in this phenyl ring, 3 hydrogens will participate, and this hydrogen will participate. So, for this molecule, how many tautomers will be possible? You have 3 plus 1 4 and 3 plus 1 4, 8 tautomers are possible for first molecule. Similarly, for second molecule, 1 hydrogen, NH hydrogen, and here 3 hydrogens, 2 at ortho position, 1 at para position will participate in tautomerism, and here this hydrogen will participate. So finally, how many hydrogens will participate in tautomers? 3 plus 1 plus 1, you have 5 hydrogens will participate. Means you will have 5 tautomers. In this molecule, how many tautomers? You have 5 tautomers. From first molecule, you have 8 tautomers. So finally, the total number of tautomers will be 13 tautomers. What is the answer? 13 is the answer. The total number of head-to-tail isoprene linkages in the following molecules. Head-to-tail. You know the isoprene unit. Okay, these are isoprene unit 2-methyl 1,3-butadiene. Suppose if you take another isoprene unit, this one 2-methyl 1,3-butadiene. Here electrons moves like this. So here there is a formation of bond, CC bond. You will get methyl. Here there is a double bond, and here there is a formation of new sigma bond. This is a new sigma bond, and this is the double bond, and this is a methyl group. Okay, this is a head-to-tail arrangement, both the methyl groups on same side, and this is a bond between two isoprene units. Okay, how many units are there? Okay, here methyl, and this is isoprene unit. This one is isoprene unit, and this is the bond, and this one is isoprene unit, and this one is isoprene unit, and this is a bond, and you have isoprene unit. So in this case, how many head-to-tail isoprene linkages are there? Here this one is 1 and this one is 2, and from this end this is isoprene unit and this is a linkage, and this one is another isoprene unit, and this is a linkage between this isoprene unit and this one. So here how many head-to-tail isoprene units are linkages are there? Here you have 2 head-to-tail isoprene linkages. So this one is not head-to-tail isoprene linkage. Okay, this one is not head-to-tail. It's a tail-to-tail linkage you have here. So how many head-to-tail isoprene linkages are there? You have from this side you have 2 head-to-tail linkages, and from this side you have 2 head-to-tail linkages. So finally you have 4 head-to-tail linkages, 4.